So on homework day 8, they're going to keep with that thing where we were doing those fractional exponents where we could rewrite them with the radical sign in there, only this time we've got fractions. If I have 1/9 to the 3/2 power, it means that I'm going to do the square root. Again, the 2 isn't really necessary, but I'm going to put it in there for effect of 1/9 cubed, right? When we switch it around. So we said we were going to start by doing the radical, the square root of 1/9. Well, when you think of the square root of 1/9, just think of what the square root of 9 is. The square root of 9 is 3, and so I'm going to have 1/3, right? That square root or any root of 1 always stays 1, so you don't have to worry about the 1 a whole lot. But the square root of 1/9 is 1/3. Then I have to take my answer to the 3rd power. So if I take 1/3 to the 3rd power, again, 1 to any power is still going to be 1. And 3 cubed, 3 times 3 times 3 is 27. So again, if you want to check that with your calculator, that fraction exponent needs to be put in parentheses. So you would type this one in as 1/9, the caret key, to the 3/2 power. And so when you put that exponent, that's a fraction. Even though on our paper it doesn't have parentheses, on your calculator you need to put the parentheses around that exponent to get it to work right. So on the next one there, you have 32 to the negative 4/5 power. If I have a negative exponent, the first thing I want to do is the reciprocal of my base. That's what that negative exponent means. So I would do the reciprocal of 32 and make it 1/32 to the positive 4/5 power, right? To get rid of the negative exponent, we do the reciprocal, makes our exponent positive. Now we have a problem that's pretty much like the first one was. Now that my exponent's positive. So my denominator is 5. I'm going to do the 5th root of 1/32 and take my answer to the 4th power. The 5th root of 1/32. What would be the 5th root of 1/32? The 5th root of 32 is? No? Because if you did 4 times 4 times 4 times 4 times 4, you'd have a really big number, right? 2, right? 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 1/32 would be 1/2. And then I'm going to take my 1/2 to the 4th power. And if I take 1/2 to the 4th power, I'm going to get 2 to the 4th? 16, exactly. So 1/16. Same thing, if you would want to type that in and check it with your calculator, the 32 you don't necessarily need parentheses around because it's not a fraction. You could use them if you wanted to, but 32 caret, and then in parentheses, you're going to do the negative 4/5 power. It should give you 1/16. So number 2, we want to simplify 81 to the negative 3/4 power. First thing you always want to do, if your exponent is negative, which it is the reciprocal of my base. So the reciprocal of 81 would be one over 81. So I'd write it as 1/81 to the positive 3/4 power. Exactly. Now I can simplify it once my exponent is positive. So rewriting that as a radical, I'm going to have the 4th root of 1/81, and then I'm going to cube that answer. So I have to think about what's the fourth root of 81. Three. So the fourth root of 1 over 81 would be 1 over 3, 1/3. And then I'm going to cube 1/3, so 1/3 cubed would be 1 over 27. So 1 over 27 would be my first answer there. So the second one there, again, I have a negative exponent. So if I have a negative exponent, I have to do the reciprocal of my base. What's the reciprocal of 1 over 32? It'd be, not stay the same. I got to flip it, so it's going to be 32 over 1, which is just 32 then, right? So I'm going to do 32 to the 3/5 power. So I'm going to do the 5th root of 32 and cube that answer. So the 5th root of 32 is 2, and then 2 cubed is 8, exactly. So when my exponent is negative and I started with a whole number, I ended up with a fraction. When I had that unit fraction, 1 over my number ends up with a whole number.
So if your fraction's in parentheses, then you flip it?
Nope. If your exponent is negative, then you flip it.
Oh, okay.
Doesn't matter if your fraction's in parentheses or not, but if you have a negative exponent, you flip it. If your exponent's positive, then you just solve it. So notice on the third one there, this one has a negative exponent, but the second one doesn't have a negative exponent. So the first one we got to flip over before we start, but the second one we won't. So if I'm going to do 8 to the negative 3/4, since my exponent is negative, I got to do my reciprocal. 1 over 8 to the positive 3/4. So then rewriting that, positive 4/3. I'm going to go, we can't take the 4th root of 8. It's because I wrote it the wrong way. 4/3. How about I write the right number? 1 over 8 to the positive 4/3 is what we were doing. So the cubed root of 1/8 raised to the 4th power. So the cubed root of 1/8 is, so 1 over 2. And then if I take 1/2 to the 4th power,
$16.
1 over 16, yep. 1/16. Now the second one there doesn't have the negative exponent, so they're going to throw some in there every once in a while just to make sure you're paying attention. There's not a negative exponent. We just go ahead and solve it by doing the cubed root of 1 over 125, and then we're going to square that. So the cubed root of 125.
I'd say 5.
You're right. 5 times 5 times 5 is 125. So I'm going to get 1/5. And then I'm going to square that. And 1/5 squared would be
1/10.
5 times 5 is
Oh, 25.
25. 1/25. So 1 over 25 for your answer. 4, 5, and 6. They want you to simplify the expression, and then when we're done, write using only positive real number exponents there. If I'm going to take something from the bottom and move it up to the top, the sign is going to change on it because I'm doing the reciprocal of the value. So what we're going to do is take anything that's in the denominator and move it up to the top so we have all multiplying in there. So I'm going to say that I have a to the 3 halves, which was on top, so I'm leaving it alone. A to the negative 1/4, which again was on top, so I'm leaving it alone. But the bottom one, when I move it up, is going to become a to the negative 1/3. Since I moved it from the bottom to the top, I have to change its sign. Now I have to follow my rule. When I'm multiplying with the same base, my rule is to add my exponents. So I'm going to work with my fractions. Since I'm adding and subtracting fractions, I have to have a common denominator. So I'm going to find my common denominator. I have 2s, 4s, and 3s. They all go into 12 and make my equivalent fractions. I'm just going to make one big fraction. 2 goes into 12 6 times. 6 times the 3 would be 18 for my first one. 4 goes into 12 3 times. 3 times that minus 1 would be minus 3. And then 3 goes into 12. 4 times my minus 1 would be minus 4. 18 minus 3 minus 4 gives me a to the 11/12 power. Now that 11/12 is your exponent, so it's not right by the a, it's raised up, right? So you're really just adding and subtracting fractions. Yeah, you could do it on your calculator, but we like to practice. So number 5, same thing. I want to move everything up to the top, so it's just a plain multiplying problem because then I can add my exponents. The y to the 1/3 is going to stay the same because it was already on top. I'm going to move the y to the 1/4 from the bottom to the top, so now it's going to be y to the negative 1/4. I'm also going to take the y to the negative 3/4 and move it from the bottom to the top. So now that one's going to be y to the positive 3/4. So the ones from the bottom, when I move them up, the signs are going to change. Again, I'm going to find my common denominator. In this case, it's going to be 12 again. And make my equivalent fractions. 3 goes into 12. 4 times. 4 times the one on top is 4. 4 goes into 12. 3 times. 3 times minus 1 would be minus 3. 4 goes into 12. 3 times 3 is 9. Positive 9. So 4 minus 3 plus 9 would give me so I get y to the 10 over 12, but we know that with fractions, we always want to simplify them, and we can reduce that down, right? If we reduce that down, we're going to get 5/6. So y to the 5/6 power is going to be my answer. So number 6, if we rewrite that one so it's just a multiplying problem, what should I have?
A minus 5.
5 halves.
Yeah, 5 half. A half.
A to the 1/2.
A and 1/3.
A to the 1/3, exactly. So that 1/3 became positive instead of negative, and now I'm going to add my exponents. My common denominator would be?
I'd say 6.
6. I'd say 6 too. And so, 2 goes into 6.
3.
3 times that minus 5
Negative 15.
is negative 15, yep. 2 goes into 6 on the second fraction. 3 times the 1 is 3, and then 3 goes into 6. 2 times the 1 is 2. So I have negative 15 plus 3 plus 2, which would give me negative 10. I have a to the negative 10 sixths. First thing, I can reduce that down, right? If I reduce 10 sixths, I would get 5/3. So I'd have a to the negative 5/3. My other thing is, I only want positive exponents and not negative exponents. How do I rewrite that so I have a positive exponent?
Just take the money. 3/5? No?
Nope.
Okay. How do you write that?
Think about when I had just an x to the negative 2. What did I do with x to the negative 2? I wrote it as 1 over x squared, right?
Oh, yeah.
So what do I have to do with the a to the negative 5/3?
1 over a.
1 over a to the positive 5/3, right? So I'm taking it from the top, moving it to the bottom so the sign changes. Kind of like here, it was on the bottom, and when I moved it to the top, the sign changed.
So that's the answer?
That's my answer, yep. 7, 8, and 9 are your rules for raising to a power. Think about when I had x to the 3rd power and I raised it to the 4th power. What did I do with my exponents? What's my rule when I raise to a power? I'm going to get x to the 12th power because I'm going to take 3 times 4, right? So same thing applies here. They're just throwing some fractional exponents in there. They're checking, do you still know this basic rule once I start throwing fractions in? So if I'm going to simplify, I'm going to do b to the negative 5th, and I'm going to multiply that by 1/5 because that's my exponent on the outside. I'm going to do a to the positive 5/4, and I'm also going to multiply that by 1/5 because I got to raise each of those to the 1/5 power, right? So if I multiply my exponents here, if I take negative 5 times 1/5, I get negative 1. So I'm going to have b to the negative 1 power. Right? 5's cancel out and I get negative 1 there. If I have a to the 5/4 and I multiply by 1/5, I'm going to get a to the 1/4, exactly. Because the 5's are going to cancel out again. Not that that always happens, but it did on this one. One little thing we need to fix with our answer, because guess what? We don't want that negative exponent. What am I going to do with my b so that I don't have a negative exponent? I could put a 1 on top, but since I have the a to the 1/4, if I put it together, I'm just going to move it down underneath the a to the 1/4, right? So I'm going to have a to the 1/4 over b. And I don't need to the 1st power, so I'll leave that off.
That's all you have to do?
That's all I have to do. Take it from the top, put it on the bottom. We did that before, right?
Was that last week?
Yes, probably.
I can't remember, no.
That was probably the first week. So number 8, same thing. I'm raising to a power, so I'm going to multiply my exponents. So I'm going to have b to the 2/5 times 3, and then c to the negative 1/5 times 3. So what is 2/5 times 3?
Two-thirds.
I don't think so.
Oh, no? How come? I thought you put the 5 there.
You have 2/5 times 3. 3 is over 1. You can't cancel on this one, so you just have to multiply. 2 times 3 is 6, and 5 times 1 is 5. So 6/5 power, right? What is negative 1/5 times 3? Because we got to do c to the negative 1/5 times 3.
3/5.
Negative 3/5, right? Negative 3/5. Oh, I've got that one that has the negative exponent. I don't want a negative exponent, so what am I going to do?
You are just going to write it as b 6/5 over c 3/5.
Exactly. I'm just going to put it down on the bottom to make my exponent positive. That's exactly what I'm going to do. So number 9, how are we going to start that one?
c 1/4 times negative 2/5.
Uh-huh. And then?
A 5 times negative 2/5.
Okay. So we know we're going to multiply our exponents. If I take 1/4 times a negative 2/5.
Are you going to cancel out your 2's?
I would, yes.
Okay.
Yeah, I'm going to reduce it down, make that 1 and make that a 2. So I'm going to get
A half.
negative, whoop,
Oh.
because I still have this 5 here, right?
Oh.
I can cancel that out.
1/10 then.
Negative 1/10. C to the negative 1/10. How about on my A's?
Cancel your 5's.
Cancel my 5's. I'm going to get
Half.
not a half,
Negative.
not negative a half.
Oh, what is it then? I'm missing something.
It's going to be negative
Oh,
2 over
2,
1,
okay.
so just negative 2, right?
Yeah.
Uh-oh, now what happens? They're both negative exponents.
Yeah.
How am I going to write my answer?
Put them both on the bottom.
Put them both on the bottom. What's on top?
1.
1, exactly. 1 over c to the 1/10 and a to the 2nd. So those aren't so bad once you kind of figure out what you're supposed to do, right? Okay, now we're switching gears. We're going over to square roots, simplifying some radical expressions that are irrational so they don't come out to nice whole numbers. So, keep in mind your perfect squares. Somewhere in your head or on your paper, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and so forth. Remember I told you the other day you probably want to have a list of your perfect squares, perfect cubes, and those things. So we're working with square roots. We want to look at our list of perfect squares. I want to rewrite this in simplified form. So what I want to do is find the biggest perfect square that divides evenly into 45. So this is what's going through my head. These numbers are all bigger than 45. 36 doesn't divide into 45. 25 doesn't divide evenly into 45. 16 doesn't, but oh, 9 does. 9 is my biggest perfect square that divides evenly into 45. I'm going to rewrite it as 9 times 5. 9 times 5 is 45, right? I'm then just going to do the square root of the front one because the front one is a perfect square. The square root of 9 is 3. So that's a nice whole number. It's no longer underneath the radical sign. It's just a plain 3. This one I can't simplify. I don't really need the times sign in front of it, so I just put it in as 3 square root of 5. It means 3 times the square root of 5. We just don't put the times sign there. So number 24, we want to write that in simplified radical form. I want the biggest perfect square that divides evenly into 24. If you look at that list of perfect squares, what divides evenly into 24?
4 or 6, right?
4 is on my list. 6 is not, right? It's going to be and 6 because 4 times 6 is 24. So the square root of 4, that's my perfect square, times the square root of 6. And then I'm going to simplify the square root of 4. The square root of 4 is 2. So the 2 goes in front, and the square root of 6 is going to be behind it. 2 times the square root of 6. Square root of 32. I want to simplify the square root of 32. So looking at my list of perfect squares, what's the biggest one that divides into 32? 8. Is 8 a perfect square? It does divide into 32.
Yeah. But we're not looking for that.
Can you do the square root of 8?
No.
No. It's got to be a number that's a perfect square.
4 then.
4 does go into 32, but it's not the biggest one.
Oh. 6.
6
No.
isn't on my list. So here's what I'm thinking. 36 is too big.
Yeah.
Does 25 divide evenly into 32? No. Does 16?
Yep.
Oh, there's the number I want to use. So I'm going to say that it is 16 times 2 to get 32. And the square root of 16 is 4. So I get 4 square root of 2 for my answer. Now what happens if Charlene said it's 4? Okay? 4 times what is 32? 8. Square root of 4 is 2, and I get 2 square root of 8. If I put 2 square root of 8 in, they're going to tell me it can be simplified further because 8 can be factored out, right? 8 can be written as 4 times 2. And then I can take the square root of the 4 again. So now I have 2 times 2 times the square root of 2. And 2 times 2 is 4 times the square root of 2. So I can get there eventually.
We don't want that one.
But if you find the biggest one first, it was a whole lot shorter, right? So that's what I'm thinking when I'm simplifying, is I'm always thinking about, okay, these ones are all too big, and I'm working my way backwards down my list so that I pick out the biggest perfect square when I simplify. We're going to get more practice here on the next ones. Now they're throwing in some variables. When you take the square root of something with an exponent, if you have an even exponent, it is a perfect square. The square root of something with an even exponent, you do half of. So, forgetting that that 12 is there for a minute, if I'm just doing the square root of u to the 10th, all I'm doing is doing half of that and taking it out of the square root. The square root of u to the 10th is u to the 5th, because if I take u to the 5th times u to the 5th, I add my exponents, and 5 plus 5 is 10. So we are going to simplify something where the front number is not necessarily a perfect square, but for now, the variable will be. So when I simplify this, I think about the square root of 12. 12 is not a perfect square, so I want to factor it. I want to pick out my biggest perfect square that goes into 12. What times what should I use for 12?
4.
4 times 3, right? So I'm just going to write it 4 times 3 times u to the 10th. Now I'm going to take out my perfect squares. This time I have 2 perfect squares, the 4 and the u to the 10th. So the square root of 4 is 2. The square root of our u to the 10th is
2.
We just did it over
5.
here. U to the 5th, half of 10 is 5. I can't do anything with this 3, so that has to stay underneath the square root. So I get 2u to the 5th square root of 3 for my answer. So on number 14 here, we're going to do the square root of 28v to the 8th. 28 is not a perfect square. It's not a number on our list. What's the biggest perfect square that divides into 28?
I'd say 7,
But 7 is not a perfect square.
no. 4 then.
4. Yes, 4 is
Well,
what we
that's
want to
useful.
use. The 7 happens to be with the 4 because 4 times 7 is 28, but 4 is our perfect square. So we have 4 times 7, and then we still have times the v to the 8th power. Now we have to take out the square roots of our perfect squares. 4 is a perfect square. The square root of 4 is 2. V to the 8th will also be a perfect square. The square root of v to the 8th would be v to what power?
4.
4, exactly. Half of 8 is 4. The 7, can't do anything with that guy. He's not a perfect square, so he's going to stay under the square root sign. So we get 2v to the 4th square root of 7.
I haven't did these, so these must be coming up, huh?
Yes, these maybe probably are at closer to the end of your pie chart, or the end of your section. So number 15 here, we want to do 18w to the 4th. The 18 again is not a perfect square, but we can factor it. What should we factor 18 into?
No?
It's got to be a number that's a perfect square. So 16 doesn't go into 18, but 9 does, right? So 9 times 2 is 18. And then we have the w to the 4th. So we want to take out our perfect squares. What can we take out of there?
9.
The square root of 9 is 3. What else can we take out of there?
Your W4.
W to the 4, and the square root of w to the 4th is
2.
w to the 2nd. And the 2, can't do anything with him. He stays under the square root. So 3w squared square root of 2 is your answer.
So your problems are always going to be like that? Because I'm thinking you could do something with the 2.
No, you can't do anything with the 2.
Okay.
Because the only factors of 2 are 1 times 2.
Yeah.
And so there's nothing you can do with it. You can take the square root of 1 all day. It's still 1.
Okay.
So, can't do anything else with that. So now, we're just going to get a little bit longer. Notice that now we have some exponents that are odd. If our exponents are odd, what we're going to do is factor out one of the variables, which will leave me an exponent that's even that I can simplify. So what I'm going to do with number 16, first of all, is my 50 is not a perfect square. I want to factor 50. What's the biggest perfect square that divides into 50? 25. So I'm going to make 50 25 times 2. That's the same thing we've been doing. Now here's the new part. We have an s to the 5th power. Since it has an odd exponent, we're going to take 1 out and we're going to factor it into s times s to the 4th power. Now the t to the 12th has an even exponent. That's what we want, so we're going to leave that one alone. Now we're going to take out all of our perfect squares. So the square root of 25 is 5. I can't do the 2, I can't do the plain s, but I can do the s to the 4th. What's the square root of s to the 4th?
2.
S to the 2nd. And I can do the square root of t to the 12th. The t to the 12th would be t to the 6th. So underneath my radical sign, underneath that square root, I'm going to have a 2 and an s left over. So 5s squared t to the 6th square root of 2s is what your answer is going to be. So anytime you have an odd exponent, you're always going to end up with that extra variable inside because it wasn't a perfect square. So number 17, 27. 27 is not a perfect square. I want to factor 27 into what? Nine, exactly. 25 doesn't work, 16 doesn't work, but 9 goes into 27. 9 times 3 is 27. T to the 6th. Should we leave it alone or should we factor it?
Leave it alone.
Leave it alone because it's already even. U to the 11th. Should we leave it alone or should we factor it? Factor it, and what should we factor it into? U times u to the 10th. I always just take 1 out, which is going to leave me an even number. Now I got to take out my square roots. What can I take out of there? Square root of 9 is 3. Square root of t to the 6th would be t to the 3rd. Square root of u to the 10th is u to the 5th. And what do I have left under my square root? A 3 and a u. So 3t to the 3rd, u to the 5th, times the square root of 3u is my answer. Number 18, that must be the last one on the page, huh? Number 18, looking at 54. 54 is not a perfect square. It's not one of my numbers on my list, but I bet I can factor it. What should I divide into 54?
6,
Is 6 a perfect square?
3. No? But 9 times 6
Ah, I like the 9 answer better than the 6
Oh.
answer because 9 is my perfect square. It happens to be 9 times 6 being 54.
Well, see, that confuses me.
So when you look here, I'm doing 54. 64 doesn't work. 49 wouldn't, 36 wouldn't, 25 wouldn't, 16 wouldn't, but 9 does, right? 9's on my list of perfect squares. 9 times 6, 54. The x to the third, do we need to factor that one?
Yep.
Yep, what do we factor it into?
X.
X and
X. 3.
X, 2.
Oh, 2.
Right, if I take 1 out, I've got 2 left over. 1 plus 2 is 3. How about the w to the 7th?
Yep.
Should I do with that one?
3w6.
Exactly, w and w to the 6th. So now that I got it all factored out, now I can take out my square roots. What am I going to take out?
Your 9.
Square root of 9 is?
3.
3, yep.
Well, the x2,
The square root of x2 would be
x1.
x1, so just an x, exactly. Square root of x squared is x.
And then your w6.
W to the 6th, the square root of w to the 6th.
5. Oh, 3.
3.
3.
And I have what left underneath my radical?
6x.
6x. So we get 3xw cubed square root of 6x.
What about the other W?
Oops, gosh, what about that other w? I better put that one too. W. Oh, forgot that one. Good thing Joel's paying attention. So, since both of these were odd, they both had a variable left over underneath my radical. Alrighty. We'll work on those for about a half hour. And do the next page. Or two.